Let's start Schrodinger time-dependent wave equation. As standing wave equation has been considered, psi can be written as a e power I kx minus omega t. Here, two relations are going to be used, which are p is equal to h cross k as well as e equal to h cross omega. First one, p is equal to h cross k. From that, propagation constant k can be written as p by h cross. And the next one is equal to h cross omega. From that, omega can be written as e by h cross, and it is taken as equation number 4. So these two equations, that is 3 and 4, has to be substituted in equation number 1, that is psi is equal to a e power I kx minus omega t. So equation will become psi is equal to a exponential of I. Instead of k, I have written p by h cross into x minus, instead of omega, e by h cross into k. So next step, psi is equal to a exponential of, in the previous step, both the terms h cross is common. So it is taken as a common factor. So with the exponential I by h cross px minus et. This is equation number 5. Next step, I am going to differentiating it with respect to x, and it is differentiated as a second order 1. So dou psi by dou x can be written as a exponential of I by h cross px minus et. This will be written as it is, and with respect to x means we will get ip by h cross. So in this, a into exponential term can be written as a psi. So in the next step, it is written as dou psi by dou x is equal to ip by h cross. Instead of a into that exponential term, I have written as wave function term psi. Then one more time it has to be differentiated. So dou square psi by dou x square, which will be written as I p by h cross the whole square into psi, and this can be taken as an equation number 6. We know that I square is equal to minus 1. So therefore equation 6 will become dou square psi by dou x square is equal to, instead of I square term, I have substituted minus 1. So minus p square divided by h cross square into psi, which is taken as equation 7. And next is p square psi is equal to minus h cross square dou square psi by dou x square. This is equation number 8. So moving to the next step, now I am going to differentiate it. So as a differentiation part, it will produce the result as psi is equal to a exponential of I by h cross px minus et. So this equation is going to be differentiated with respect to time. So therefore the focus is going on with the second term, that is et. So a term, exponential term, I have written it as it is. The second term has to be differentiated, that is minus ie by h cross. So this can be written in a simplified form as dou psi by dou t is equal to minus ie by h cross into psi. So this is again written in the format of E psi is equal to minus h cross by I into dou psi by dou t. This is taken as equation number 9. So two equations we have got, 8th one and 9th one. So with respect to, we know that total energy can be written as a sum up of kinetic energy and potential energy. So here we know that kinetic energy can be written as p square by 2m, and the potential energy, it is represented by the letter v. It is a function of position, and the sum up can be written as equation number 10. As a next step, I have multiplied the equation 10 by psi. Both sides I have multiplied. So E psi is equal to p square by 2m plus v of psi. So that is E psi can be written as p square by 2m into psi plus v psi. So this is equation number 11. To the next step, I have done the substitution. So equation 8 and 9 has been substituted in equation 11. So we will get minus h cross by I dou psi by dou t, which is equal to minus h cross square divided by 2m into dou square psi by dou x square plus v psi. So here in the previous step, left hand side I have multiplied and divided by I term. So left side will become I h cross divided by dou psi by dou t, which is equal to right hand side as it is I have written, because we know that I square is equal to minus 1. So equation 12 has been produced. So this is the famous Schrodinger time dependent wave equation. So let's meet on next.